Okay, today's lesson is 2.6. This is going to cover completing a function table. It should be page number 12 in your notebook. And completing a function table is building off of what we already know about functions. We've learned how to identify them, and we've learned how to use the vertical line test to see if lines on a graph are functions. So today we're going to complete tables. So that's actually the goal. We're going to complete a function table that follows a function rule. And function rules are like an equation. So every function has some sort of rule that dictates the conditions of the relationship between the independent and the dependent variable. A couple key terms before we begin today. First key term, again, we've already kind of defined what it is to be a function, but this is a alternative definition. And really what a function is it takes some input, and based on some rule, and this is what we're talking about, some equation or some graph, it produces an output. And you can see this represented visually right here to the left. We've got some input that goes into this function machine, which is the rule, and it produces, or it kind of dictates what the output is going to be. And then the second part of, or the second major term today is ordered pairs. So an ordered pair is a pair of an input and its corresponding output value. So this is like a coordinate point, right? We've seen this represented as x, comma y, or it could be represented as a comma b, where a is the independent variable and b is the dependent variable, or it could be represented as x comma f of x. So f of x is a function of x. This is going to be something that you see now replaces y. So if I write this as a visual kind of matching or mirroring this diagram right here, we have x. It goes into this function, which is f of, and out comes the product, which is f of x, which equals y. So these f of x, function of x, is the same thing as y, but because the relationship between the two is a function, we can switch out y and x. And you'll see that happen as we go through some of these examples. So let's do the first example today. So the example direction is follow the rule and complete the table. So take a second and look at what the table is and try to figure out what the rule or the pattern is. We've got our input, we've got our output. The input is cat, the output is t. The input is house, the output is e. The input is u, the output is u. The input is stem. What's the output going to be? Well, it looks like the inputs are all words, and the output is the last letter in the word. So cat, the last letter in the word is a T. House, it's a E. U, it's a U. So stem, it should be an M, right? So our output here would be an M, and then the last one, it gives us the output Z, and it wants us to provide the input. You figure out what your input is. For me, if the output is Z, I know the last letter has to be a Z. Now I'm just thinking of some word that ends with a Z. Really the only word I can think of right now is buzz. So that's kind of what we're going to do today. You get some table and you've got to figure out what the rule is, and you've got to finish out complete the table. So look at example number 2. Follow the rule and complete the table. So the input is 3, the output is Tuesday, the input is 6, the output is Friday. What is the input for the output Thursday? What is the input for the output Wednesday? What is the output for the input 7? And then the last one, obviously. So we've got 1, 2, and hopefully you figured out what the pattern is, what the rule is. We got 1, 2, 3, 4, 5, 6, 7. So if I write it out like this, and I know that 3 is Tuesday, well, I know that After Tuesday comes Wednesday. Then I know Thursday. Then I know Friday. And I know Saturday. So what's 1? Well, 1's got to be Sunday. And 2's got to be Monday. So we're just finishing out this. Thursday's 5. Wednesday's 4. 7 is Saturday. And then the last one, which we don't have, is 1 is Sunday. So these are more conceptual examples. Let's get into some actual algebraic examples. So here we have our rule, the graph, and it gives us this table, and we're figuring out what the outputs are for these inputs. So if I'm looking at the graph here, if the input is 0, I go to the input axis, which is my x-axis. This is the input axis. And this is the output axis. So when the input is 0, what is the output? So we go to 0 on the input, and the output is 1. So we got 1 right here. When the input is 1, so the input is 1, what is the output? We go up to where the line is, and the output is 3. When the input is 2, the output is 5. When the input is 3, the output is 7. And when the output, or the input is 7, looks like the output is 15. So you're just using the inputs to figure out what the output is for that point on the line. And again, you can write these as ordered pairs, where the input is matched with its corresponding output. So if we wrote ordered pairs, that's what we would write them as. Example number 4, again, same as the previous example, we're just filling in the table. The only change now is instead of y, we've got f of x. So in this previous example, oh my lord. In this previous example, we had y, x and y. In this example, we've got f of x. And remember, f of x and y are essentially the same thing, except you use f of x when the relationship between the two variables is in fact a function. This passes the vertical line test. We can take y out, and we can put f of x in. So when x is 0, what is the output, or what is f of x? Well, it looks like 0 is right here. F of x is 4. When x is 1, what's its output? Corresponding output is 10. When x is 4, so we've got when our input is 4, what is the output? The output is 28. And the last one, when the input is 5, what is the output? The output is 34. So that's how you're going to complete the tables when you're given a graph. And then 2 more examples. How are you going to complete the table when you're given something like this? So the rule here is the equation. F of x equals x plus 3 gives you x, wants you to figure out what the output for the inputs are. And you're going to use this equation to do so. So the first example, or the first input, is -2. So we're going to put -2 into the equation for x, as that's what it represents. So where x is, we're going to put the -2, and then we're going to add 3. -2 plus 3 is 1, and that equals our output. And our output here is f of x. So when x is -2, our output is 1. When x is -1, we put -1 in, add it to 3. -1 plus 3 is a positive 2. Our output is 2. When our input is 3, we put in 3. 3 plus 3 is 6. Our output is 6. Last one, 5 goes in for x. We've got 5 plus 3. 5 plus 3 is 8. Our output is 8. Last example today. Same exact thing as the previous example, except now the equation is a little bit more complex. So our input here is -5. So we're going to go ahead and put -5 into the equation. So we've got 8. We've got 8. X, this is being multiplied, so we know that they're being multiplied. When we put in -5, we're going to multiply it, and -5. So, order of operations here, 8 times comes before -5 minus, so 8 times -5 is -40, and we bring this down, -40 minus 5 is a -45. So that would be our output here. Your output is a single value, so you'll simplify the equation or the expression until you have a single value. So for the second one, we've got -2, and we're putting that in, so we're going to multiply it to the 8, and then we're going to subtract 5. So we've got -16 minus 5. -16 minus 5 is a -21. Now you'll notice that these functions follow a rule, so that sometimes you can use just the pattern of the numbers to figure out what the next sequence is if there is some pattern that's easy to identify. Sometimes there is, sometimes there's not. Last two, we put in 0 for x, so we've got 8 multiplied by 0 minus 5. Anything times 0 is 0, so 0 minus 5, and 0 minus 5 is just -5. Last one, 6. So when we put in 6 for our x, what is our output, or what is f of 6? We've got, 8 times 6 minus 5. 8 times 6 is 48. Minus 5. 48 minus 5 is 43. So that is our output here for 6. So that's how the inputs and the outputs work when you're given a table, or when you're given when you're given an equation, or when you're given a graph. Good luck on the homework. Please message your classmates or me in Schoology if you are having any difficulty.